We've had requests from many of the viewers about splines and gears. We are going to take a field trip to a company by the name of Reska Spline. It's been around for like 50, 60 years. I don't know how long. I mean, I knew about them when I was a kid and I was a tool maker. They were a competitor of ours. I happen to have been in the precision grinding of gears and master gears, helical gears, and splines. That's kind of where I cut my teeth, no pun intended. And Reska was kind enough to allow us to come out there and see how these master craftsmen produce master spline gauges for inspection, and they sell them all over the world. It's a small shop, but very, very talented people. The kind of talents that you don't find very often. It's very, very specialized. It's really an exciting trip. I know you're going to love it. So we're going to show you where we're going to go, but it's the name of it again is Reska Spline. We're going to see Michael Cass out there. He's the GM, and he was kind enough to agree to allow us to come out and talk to his employees and go through the shop. This is really going to be a great trip because we're going to show you exactly from beginning to end about how it's initially designed and every step through the process through making a master spline for inspection. Now, they don't do anything that's in production, but what they do is they provide the master settings for production. So here's an example of some splines. Now, of course, these are production splines, which is not what they do. This is a typical spline with a keyway in it. Here's another one and another one. What do splines do? Well, they allow the transfer of torque from one position to another. So the spline will fit, a male will fit inside of a female spline, and you can slide it back and forth so you never lose position, and you can transfer the torque from the input shaft to the output gear, wherever it is. See, in this case, this is a classic example. This happens to be a transmission gear that I recognize, and this spline then would fit into a female that allows the torque to be transferred from whatever that device is over to here, or vice versa. So that's what the splines do. They're very common in cars, transmissions, not so much in engines, but in transmissions and in steering. You know, where your steering column goes in and out, that's on a spline. That's how you don't lose position, and that's how you can still maintain the torque from the hands through the steering wheel down to the steering column and the mechanism. So that's what splines are all about. And I know you're going to love this trip, so Glenn, what do you say we pack it up and head on out there?
Sounds good.
Let's go, boy.
Alrighty.
Here we are, Reska Spline. Mike.
Don,
Good to see you. Good to meet you.
Nice to meet you.
Thanks for having us today.
You're welcome.
Yeah, we're excited about going through here and showing us all about splines.
Definitely.
It's a whole new world that not many of our viewers know anything about. So
no, not a lot of people know about splines.
So we're excited to see it. And you do master splines, not production, right?
We do a lot of master splines and a lot of gauges.
Beautiful for the splines. And who's this good-looking guy in the purple?
Corbin.
Hey, Corbin. Don, good to see you. Your hands are cold, man. What's the deal?
It's cold in there.
So what's your function? What do you do here?
I'm a designer, so we get parts in, and then I make the designs to the gauge.
Oh, I see. So if I came to you and if I said I had a spline here, or I mean a spline that I manufacture,
Yes.
and I want to check it, and you would make a fixture, design a
Yes.
fixture to check that part. Is that the idea?
Numbers for the your spline, and then I would make a gauge to it.
Great. We don't happen to have a spline up here of some sort, do we?
Sure we do.
Let's see if we can't show so people understand what a spline is. Ah, there we go.
This is basically a coated spline that has, for probably like a steering column of some sort.
Uh-huh.
And this is actually the shaft for it, of a tube.
So it's internal spline.
For an internal spline, which would go under it. And what splines are, they're similar to gears, whereas that when they go together, they basically have a torque to them so that they fit together really tight and snug with a real close tolerance.
And they also allow you to go vertical, right?
Right.
So that's the idea of the spline, is so you don't lose location.
Yeah,
but it allows you to go vertical.
Correct. And they transfer torque so that you have a lot of you don't have any slop in there at all when the part is
okay.
turning.
Cool. So it transfers torque, and at the same time it allows you to have movement in and out.
Yeah, if need be.
Without losing position.
Correct.
Beautiful. Okay, so now can we go back and see how you guys do it back there?
Sure.
All right, let's head in the back. Let's go.
All right.
So here we are in the back now, right, Mike?
Yep.
Okay, you want to take us through and show us, where do you want to start?
We can start back by the lathe.
Good.
Where we start all our turning.
All right, let's head over there. I'm Don.
Jerry.
Hey, good to meet you, Jerry. What's up? What are you doing?
This is called a plug gauge,
Uh-huh.
and I just finished turning this. We use a special tool for putting on the knurl, which is a diamond shape.
So you put you put the knurl on there.
Yeah.
Cool. So then, where will it go from here now?
To go to stamping. And
Okay.
then heat treat.
So put the stamping and put the name on here and so
Right here on
forth.
the flat,
Reska Spline, right?
right, and the customer's tool number and part number.
Beautiful.
And then it goes to heat treat for hardening. Comes back, gets ground.
For OD,
The grounding process.
and it may or may not get a spline in. It just depends on the job, right?
Right, at this
Okay.
point we get a spline.
Yeah, great. Beautiful. Thanks, Jerry.
Okay.
Appreciate it. Where do we go from here now,
And
Mike?
next, depending on what kind of gauges we're doing, we can go over to the mill where we can they'll cut and mill certain special areas for our handheld.
So it might be splines or gauges or whatever, right? It could be keyways, could be a number of things, right?
Correct.
All right, let's take a look at that. Let's go. You're Josh?
Meet you.
I'm Don. Hey, nice handshake, dude. I like that. What are you doing here? You're too young to know anything about this, aren't you?
29, actually.
Oh, you look younger than that. I would have carded you if I was in a bar, you know?
I get carded all the time.
I bet you do. So what's your function here?
Oh, a little bit of everything. Right now it's on the mill. Done some notches to help with the actuation of our gauges.
So I see you're using gauge blocks here as well.
Yeah.
What's that about? You have to locate,
It's on a sine function,
okay?
so I just do a little right click and then go. That way I'm always on a solid 10 degrees.
I see. So in this case, you're milling, you're 10 degrees from
Center.
right? So by doing that, you did the calculation, so you put the gauge blocks back in a pin. Hey, Glenn, can you get a shot of these gauge blocks back here? So there you go. So we got the gauge blocks back here resting on a pin, right?
Yes.
So now the next thing you have to do is you've got to pick up the center this way, correct?
Yes.
How do you do that?
Simple as an edge finder. I use an edge finder, locate my hard stop, call it 0, and then
move over from there.
move over from there. Measure the distance around the diameter, divide by 2.
So you can either do from the edge finder from the diameter, or you could pick it up from the pin, right?
Yes.
Okay. What kind of edge finder do you use, out of curiosity?
3/8 body. So I got a 200 thou shank.
Yep. So you subtract 100 or whatever.
The 100 off the diameter of that.
Beautiful.
Yep.
Great. Thanks, buddy. Appreciate it.
Take it easy.
Don't make any mistakes when you're doing your calculations. That's not good.
No. Measure twice, cut once.
There you go.
A lot of the stuff that's done will be going into the surface grinding area where they do the ODs and the IDs.
So I would assume that at this point it's probably gone out to heat treat, assuming that it's going to be hardened, right?
Yes.
So go to heat treat and come back.
Then comes the heat treat and then comes back, and then he'll do everything where he needs everything that's got to be touched up and ground to the actual size, finished size.
Within a few tenths probably, or whatever, yep. All right, let's go over there. Let's take a look.
Right here we have a surface grinder.
And who's this guy?
This is Mark.
Hey, Mark.
how you doing?
I'm Don. Good to see you.
How are you?
Great, man. Say hello to Glenn.
Who's that?
Glenn.
Glenn?
So it looks like you're going to face off.
Yeah, I'm gonna get this flat.
Power feed up. That's pretty cool. Power feed in too.
As long as you go slow.
So right here, he's just gonna flatten it off.
Yeah, we talked about crisscrossing in one of our videos, and by not moving the part and using residual magnet, of course, you get it absolutely flat.
Yes.
We had.
It's flat within a tenth.
Yeah, that's what I was saying. We showed this in one of our videos about crisscrossing like that where you don't move the surface grinder. So you take
The wheel stays set.
right. So you
Right.
you take the grinder out of the equation by doing it that way.
The magnet's on roughly.
Little residual, yeah. Just enough so you don't throw the part.
There you go.
Throwing the part's never good.
No.
Have you done that before? Come on.
About it. You see in our old shop, the surface grinder used to be along a bank of windows.
Uh-oh.
There was always one window that had a big hole in it.
Well, I've thrown parts because I used to be a grinder hand, so I've done it. You know, it happens. All it takes is one little bit too much and bam!
Really, you can't take much more than a tenth or two at a time.
Yeah, and right now, that's probably all you're taking, is I bet you're not taking a tenth off right now, based on the sparks, right?
It's just, all you're trying now is just to get it as flat as possible.
Yeah. And why do you want it that flat? Why do you need to have it within a couple of tenths?
Well, when they grind these teeth, they're going to take it in the inspection room, which you'll probably check later. Yep. They're going to run to see how straight the teeth are, and then plus the form of the teeth. So the flatter and the truer everything is, when he gets back to try to fix something, when he has to take it out, put it back in, he picks everything back up.
Off the face, yeah. So
Closer that this concentricity band in the face are, the truer he picks it back up.
I see. So you got to be
You can
good.
take it in and out and still not lose your concentricity. Is still right there.
Yeah, makes sense.
Yeah.
Okay. Appreciate it. Well, thanks for showing it to us.
All right.
Appreciate it, bud.
Yep. Thanks, Mark.
All right, where do we go next, Mike?
Next we can go over to the EDM machine for when we actually rough cut our splines out. From
Well, let's go.
rings.
Oh, that's cool. Let's go.
Okay, well, after both the rings are
Ground
turned
flat.
and ground and come back from heat treat and they're ground flat, they come in with just a round hole in them.
Yeah.
And what we need to do a lot of times on the internals and some external plugs that don't have handles on them, what we'll do is we'll rough cut them in the EDM machine to save the grinders a lot of extra stock
Wow.
to take out.
And I'll
a
tell
lot
you,
of time.
what, back when I was grinding gears and splines, we didn't have EDM.
Right.
Oh, that was back in the 50s.
Saves a lot
I
of
like to
time
admit
and a
that,
lot
yeah.
of grinding.
So obviously you've got the ability to do the calculations for the EDM to
Yes, and
provide, so it can do helixes and all that stuff. Is that
We don't do the helixes in there, but we do account for the helix angle.
so? You leave stock in there so when you grind it.
In engineering, what we do is we account for all that, the calculations for the EDM process. And then what we'll do is we'll take the program that we make in the EDM and we'll bring it in and load it into the EDM machine.
Beautiful. So we got an EDM machine running.
We actually have it running at the moment.
Let's
for
take a
one
look.
of our, internal rings right now. And it's a little tough to see at the moment. This is a electronic discharge machine that actually tries and cuts the.
Yeah, you really can't see it cutting.
It's a real
can
thin
you?
wire that cuts the actual spline out of the steel.
Yeah. So if you look up here at the wire, so look how fast that wire is being burned up. And you can only use a wire once, right?
Yes. Once
So
it's
go-
done, it's done.
It's done.
This is a brass wire that's used on these.
On cutting. Yeah, it's hard to see it, but you can see the wire right there. You can see it kind of. Great. Oh, that's pretty novel, pretty cool. What's the fluid that's in? Is this like a
This is
special
just-
EDM fluid?
It's just water.
It is. Huh.
Once that's burned,
And where do we go next?
we actually just, you get something similar to this, and you'll see, with the water, if it sits in there, you'll get a little bit of discoloration there.
Uh-huh.
And then what they'll do is they'll take it back to the ID machine and they'll clean up the ID on this, because this is just a rough cut.
So they'll grind the ID, and then from that they'll grind start grinding the teeth, I would assume.
And then we will go over to the actual internal spline grinders, and that's when we'll start grinding the teeth.
Oh, great. So where do you want to take us next? This is really cool. I really
Go
like
over to
this.
the internal machines and you can see what they do there.
Let's go. Okay, Mike, so this is one of the internal machines, I assume. Is that correct?
Yeah, so what we have here is a internal spline grinding machine with the capabilities of doing helical work.
So so this is, of course, the grinding wheel,
Yep.
which is going to be moving in and out to
Yeah,
grind
this
this.
whole arm will move inside the part here, which is in a chuck, and they'll index it on the plate.
There's a master index there
We have an index plate on the side here,
with the correct number of teeth, and
which whatever how many teeth they have on the gear.
beautiful.
So they'll turn that for each tooth they need.
Well, these jobs are all custom. I mean, everything is set
Every spline we have is custom. Nothing is production here, unfortunately.
up. So you've got to have a lot of fixtures and a lot of capability of doing all of these different varieties, right?
Yes.
Very cool. I hear something in the background grinding there. You want to tell us about that? Or can we go over there and take a look?
Yes, what we have over there is probably one of the biggest gauges we've done ever here. This is also, these machines are capable of doing external also.
All right, hold on here a second. I'm Don.
Kevin.
Good to see you, Kevin. I hear you over here grinding away. Reminds me, I used to do this when I was a kid. So I know about grinding gears and grinding splines and stand there and doing exactly what you're doing. I did it for several years. So I know about it, and it's a challenge. You know, getting everything on center, right? You got to get your wheel.
There's a project with this job in particular.
Yeah, this is a big part.
Yeah.
What's this thing weigh, would you guess? 150 pounds. Wow. Now, when you're all said and done, you've got to hold a tolerance over rolls, correct? And what kind of tolerance do you have to hold, would you guess?
On this particular game, it's between 5/10 and 1,000.
5/10 roughly? That's pretty close. And every tooth, and what happens if you screw up one tooth? You either start over, maybe you could hard weld it? Is that possible?
Pretty much. You know, this has got 3 pieces to it, to the spline.
Yeah.
Mess up one tooth, and it doesn't work right,
So you start over.
pretty much.
We don't want to, so we don't want to lose, we don't want to do that.
No.
And we don't want you to lose your concentration, but I appreciate you showing our viewers exactly what you're doing here, because this is highly skilled, and and believe me, I appreciate it. And I know that if you make one mistake, you got a problem. There goes the whole profit of the job. You start with another blank, don't you?
Pretty much.
You start all over again. Anyway, Kevin, thank you much. Appreciate it. Good luck to you.
What we got here is an external spline gauge. This is more of our, I guess, bread and butter gauges, which are plug gauges.
Who's this guy?
This is Brian.
Hey, Brian.
How you doing?
I'm Don. Good to see you.
Yep.
Sorry to interrupt you, but what you're doing is really interesting. We just want to take a look at it, get a good close-up shot of what we're doing, if we can do that. So you want to tell us a little bit about...
Come on in.
All right.
As you can see, we're doing external splines here.
Yeah. How many teeth you got here, do you know?
This is going to be a 32 teeth in it. Eventually it will be a taper tooth master,
Okay.
which will fit to a ring,
Yep.
stuff like that. Right now I'm just roughing it. Most of our external we rough from solid, the smaller stuff.
Sure.
You get the bigger stuff, then we'll rough that out first. But this smaller stuff, we take it right from solid.
So you've got to hold the size over pins, correct?
Yeah, this is a measurement over wires, right? And
What kind of tolerance do you have to hold when you're all said and done?
10/10,000ths of an inch.
2/10.
So for those that don't know it, take a human hair, average 3/1000ths of an inch thick, splice it 30 times,
There you go.
take 2 of those.
There you go. That's a
size-
tolerance.
That's the size we're holding right
Yeah,
there.
when you put it in that perspective, it's
That's how I tell people that don't really understand the industry.
right. It's really hair raising.
Hey!
Ah. No pun intended there.
No, not at all.
Anyway, so you were saying that when you're all said and done here, that you're going to put a taper in that.
Right. Now, what this is, right now I'm grinding everything straight. And I'll leave about a 2,000 stock envelope on it.
Okay.
Then I'll kick this rail over, and I'll strictly work on the back side and do all the tapering on that back side.
Got it. Okay.
And then you work to gauge points. You got to have a certain size in this area, a certain size in this area. So when you test it to the ring, you hit a fit range, and eventually you hit a wear out range.
Yep. So it tells you when the ring gauge is
Tells
worn.
you when the ring gauge is worn, right?
That's almost a tongue twister.
Say it fast 3 times.
So, and all that's within a couple of tenths.
Everything's within a couple of tenths.
And again,
You got spacing, you got the form, involute, the
Yep,
form,
sure.
measurement over wires, the root diameter down to the very bottom, they give you a maximum, we get under that, everybody's happy.
Yeah,
You know,
and you screw up, you start over.
you get one shot,
That's it.
one shot, they give you one plug, make it right.
How long have you been doing this?
I've been at it
Is it okay if I ask you that?
I've been at it for about 44 years.
Wow.
Doing gears and spline, not particular gauges,
Yeah.
but I've been in the industry for over 40
Good
years.
for you. Well, it's a real skill, man. I got to
Yeah,
tell you.
well, it's been a living.
Yep.
Been a
Well,
living.
thanks much. Appreciate it. Appreciate your time. Good luck. Don't lose any teeth here,
I try not to.
cavities or elsewise.
Try not to.
All right. Thanks, Brian. Now what's up next, you think?
Well, what cuts all these splines is all the wheels and different wheels we use and different harnesses. And if you look over here, this is all the different types of grinding wheels we can use, different harnesses and actual just
Yeah.
the different grain of wheels.
60J,
itself.
60K. That's 60 is
They
a
have to
grit.
do softer wheels, harder wheels, all depending on different types of steels and different types of cuts they want to use.
Yeah, K is a harder wheel than J, as I recall.
Yes,
H is softer.
yes.
So it goes H, I, J, K, right? From degrees of softness to hardness.
Correct. And then the 60 and the 80 and the 100 are the different types of grain and how compacted they are. And that's a different another way for cutting and what they have to use.
While we're in this area, I see on this cabinet here index plates.
Correct.
Can we take a peek at that?
We can take a peek in there. That's just every spline we do has just a certain amount of teeth. It could be anywhere from 2 teeth to
2,000. Not really,
God
but
only
a
knows
couple
how many,
hundred.
100 teeth easily. And every index
Holy
plate
mackerel, look at all that.
in there is for every different type of tooth.
Wow. And odd teeth, even teeth,
Odd
right?
teeth, even teeth. And we have certain customers, because we do stuff internationally.
And these are all,
So some have special setups for them, with wide teeth or, it's not always a easy index
yeah, you might have a,
divided by 360 degrees. It could be a special index where we had to make a special
yeah,
plate.
you could have 2 teeth at 60 degrees, another tooth at 87 degrees.
Correct. I mean, it can get hair raising like you said before.
Yeah.
And then just to give you a scale of the size of the amount of teeth and the size of these index plates, some of them get even bigger.
Yeah. Wow.
Just so the plates
And again,
that they have to turn for the
these-
size of the teeth. If there's 100 teeth on there, the plates get just incredibly in size.
So, and these are all within tenths as well.
Yes. Yeah, they were all
Custom made
custom made and
over the
tolerance.
years.
Yep.
A lot of big investment in all this stuff.
Oh yes.
All right, so where do we go from here?
We can go over and see some of the finished gauges that we have done over the years.
I like that. Let's do it.
So as the gauges get finished, they still have to go for inspection
And
before we ship them out. And so when they get here, we put them on the inspection table.
so these are all, if I can pick it up, can I pick it up?
Yes.
Yeah. Look how beautiful that is. Wow.
So that's after they're all finished ground and the final spline is on there.
Look at big internal.
Even a big ring gauge like this and a big internal gauge.
It's beautiful. And not cheap either, right?
Oh no, these some of the bigger ones definitely get a little up in price, but
Well, you have to put a
Good
risk
reason.
element in there too, don't you? I mean, besides profit, I mean, isn't there a risk element of maybe you scrap it once or something, or
yeah, there's always a little bit of something in there, just in case.
no, that's just 4 teeth.
That's a sector gauge. All these gauges are made for checking parts, to make sure they're still good, whether in process or in manufacture, or even after manufacture. They want to know if the part is good or bad. This is called a no-go gauge, so that would be if the part actually goes onto this gauge,
It's a
it's
problem.
a bad gauge.
Yeah.
Or a bad part.
Bad
I'm
part.
sorry.
Yeah, it's a problem.
On a go gauge, if the part goes in, and it's a good gauge. But if it doesn't go on, then it's a bad gauge.
Right. So, what do you got? Some photos here for us too?
I'm going to have some photos here. I'll show you some of the gauges we have finished, but these here are actually pretty much our what we call variable gauges that check the actual teeth, which would also check like on over pins or between pins.
How does that work? Does this move or? Oh no, this
is
that's
the indicator.
okay.
It's a digital indicator that reads, and then you just we press the handle. You just put the master in.
The master
let go
goes.
of the handle.
The master goes in here.
The master goes in the slot, and I actually show you the next picture here.
Oh yeah.
To see
Wow.
this is what we call it a RotaCheck chuck.
So you got two splines in there that rotate. Is that correct?
There's a center spline that rotates when you press the handle, and then you put the master into.
And then set it.
Set the master, and then once you take the master out, the indicator is set. Then you can put your parts in.
Got it. So you've got
And then
one that's
subtract the difference, so you know where your parts are coming in at.
So you've got one that's permanent and one that moves.
Right. So
And
there's
that's how you
two
set it.
permanent and one that moves. There's 3 sections on the spline.
Ah. Okay. Very cool.
So you're grabbing on both sides of that center section.
I see. Huh. I got it. That's really. I've never seen anything like that before. That's very cool. Has that been around much?
We've been in business for 94 years, and this has been around probably the majority of that.
Wow. I'll be darned. Never saw that before. And then I take this as the inspection room.
This is the inspection room.
Can we take a quick peek in there?
Take a quick peek through there.
Let's go.
Most of our equipment in here to check is all manual, a little on the antiquated side, but still does its job like it's supposed to. They're all Fellows machines mainly. We have lead checkers and involute checkers.
Okay. So involute checker, as I recall, it checks the shape of the tooth.
Right,
Correct?
checking form on the
The
tooth.
form of the tooth, and that's what this guy does. So it'll tell you within probably millions if you're off one way or another. So the shape has to be a particular involute shape, and if you're tipped this way, that's no good. If you're up that way, it's no good. The bottom's this way or that way. So it actually tells you the perfect shape that you need for an involute. Is
Yes.
that correct? That's great. So then that's what this guy does.
Yeah, so that's, one's basically we use for internals and one we use for externals.
I see. And then this is a lead checker, you said?
Yes.
Okay, so Mike, talk to me about the lead checker. As I recall, that checks if you're making a spline and you need to know if it's 1 degree, 2 degrees, 5 degrees. Will this tell you that? And if you're off or on, or explain it to us if you would, please.
Yeah, you pretty much want to make sure your lead is within a certain amount of, actually you're checking your tolerance within a thou, or I should say a tenth or a couple tenths within your lengths
So
on your straightness of your
the spline.
itself.
Okay, I got it. So what this is going to do, this is going to look at the spline, the length of the spline, and it'll tell you if the spline is straight.
Right.
Or if you want a taper in there, it'll tell you if there's a taper in there, correct?
Right. And
Got it.
you can check helicals on this too.
So that's referred to as a lead.
Yes.
Got it.
This is mostly what the inspector does, is most of his write-ups and stuff, and we have all the different kinds of gauge pins.
And those have to be at high tolerance too.
These are all high toleranced for checking either between the spline or over splines.
And there's an a typical inspection report.
Typical inspection report, that's all written up.
Reska Spline. Great.
Gauge blocks, these are mostly ceramic, which are
They
probably the
last
best kind, 'cause
they last forever.
They don't, heat does not bother them.
Yeah, they're not sensitive to
cold,
temperature changes, and they're stable, and they're expensive.
Yes, very expensive.
But they're probably 4 or 5 times the cost of a regular set.
Yes.
But on the other hand, the advantage is that they're stable, they never wear out.
And they're always, they never change.
Yeah, they'll be here when
Size.
you and I are gone. So where are we here now?
Well, what we have here is what we call our gauging table, or R&R table, where they do repeatability checks. Our customers will come in, and what they'll do is they will come in and they'll take their parts and check their gauges to make sure that all their parts are, and our gauges for that matter, are repeating to within their tolerances that they want them to repeat to.
So they actually get a chance to see their gauge in action.
Correct. And
Before
wanna
they
make
sign
sure
off
that
on it.
Number one, the gauge is working correctly and within tolerance. And number two, that their parts are at least correct too.
Boy, this is a big gauge.
This is similar to the one gauge that Kevin was grinding on the other machine. It's
Yep.
For one of the parts, the one he was doing was for the same part. This is just a different one.
Huh.
And
Just,
this piece over here is actually the master for it. And
This-
actually what we do with this is we put the master on. And once the master's on, we can take it over and just gauge it in. Put it in the gauge position. That master's pretty much not going to come off once it's on. Then you'll zero out the indicator in the back here. 9 microns right now. But we
Which
can
is-
zero that out. And then you would, once that's off, you put that back in the load position, and you can see now that it's
this thing has to cost more than $100.
a little bit.
I know my stuff. So
all this part here is just a stop for the actual part that we're using. The parts are pretty long.
wow, great.
And then
Great
these
stuff.
gauges over here are for a couple different parts. Same
concept again.
In the low position, put the master in, gauge it, zero it out, and then take the master out.
Wow.
Put that in. This one is a little bit different kind of a gauge, where they're checking concentricity. So we actually have it sits on a tooling ball.
Yep. On the center.
This is the master that represents their part. And then it's spring forced into there on bearings.
Yep.
So what they'll do is they'll turn this on, and then they'll just spin
Rotate
part
it.
around and check for run out.
Huh.
And on this particular gauge now, with all the different slides on this, we can actually move it out of the way. This will move down.
Down, you can
for
check
different positions and check different positions on the part. Because this one actually has a special one where you can actually move the whole master down.
Huh. That's kind of tricky. So this is really incredible. So if you don't mind my asking, are your customers from all over the world?
We have customers internationally from everywhere, from China, Germany, Korea,
Wow.
and then everywhere all over the United States. We even have Mexico and Canada.
Yeah, I could see where this is so specialized that it's just remarkable when you think about the skill level that your guys have here. I'm really impressed, and I want to thank you really for taking us through and spending your time and letting us interrupt your employees to show us how you do this.
You're welcome.
This is
Pleasure coming out.
a different world, man. I mean, this is totally different than what we see every day. You know, you go to tool and die shops, you don't see anything like this. This is very, very specialized. So we know that our viewers are really going to enjoy you sharing your skill level and your experience with us. So, well, Glenn, I think we'll just pack our stuff up and get on out of here.
All right.
So again, thanks again, Mike. Appreciate it.
Thank you. Have a good one.
So what do you think about that trip to RISKA? Was that something?
Yeah, it was really fun.
I mean, those guys there, you talk about a bundle of talent, and you know that's not something you can teach very quickly. When you think about all the gear grinding and the spline grinding that goes on over there, it's really, really complicated for shape, form, size, and the close tolerances. I mean, look at those guys are working really within a couple of tenths, or in many cases, almost millions. So what a great bunch of guys. And again, I'd like to thank Reska Spline for having us out there and allowing our viewers to take a look at this. Watch this thing from beginning to end. I think you're really going to like it. So again, tell your friends about it. Please subscribe. Pass it on to the next person. It's our job here at Suburban Tool is to pass on the legacy of our knowledge to people that are hopefully coming into our trade. And it's hard to find talented people these days. But come on into our trade, guys. We'd love to have you. And pass this on to everybody. So subscribe and tell your friends about us. So again, thanks for watching.